Welcome to the first edition of my presentation for grade 11 physics. Today I am going to provide you with solutions to our first home assignment. We had a question on electricity. You were given a question on transformers, which was number 1. On our question number 1, we had a diagram showing you the structure of a transformer. And you were supposed to name the type of transformer in question A, part 1, Roman 1. If you look closely at the diagram, you will see that we have got more turns in the primary coil than in the secondary coil, which means that the transformer in Fig 5.1 is a step-down transformer. Secondly, you were supposed to name the part labeled A. When making transformers, we make use of soft iron. So A is a soft iron core. Moving on to question B. You were supposed to suggest why the wire of the transformer coils are made of copper. We make use of copper simply because of its electrical conductivity. So the wires are made of copper because it is a good conductor of electricity. Moving on to question 1C, starting with Roman 1. You were supposed to calculate the potential difference across the secondary coil when an alternating potential difference of 240 volts is supplied to the primary coil. As we all know, that voltage in secondary coil divided by voltage in primary coil is equal to the number of turns in the secondary coil divided by the number of turns in the primary coil. In symbols, Vs over Vp is equal to Ns over Np. If you make use of that equation, you will see that the voltage in the secondary coil will be equal to 610 multiplied by the 240 volts supplied, all divided by 1600 turns in the primary coil to give us a final answer of 90 volts. Question number 1C, Roman 2. Calculate the electrical current in the primary coil if the secondary coil has a current of 5 amps, assuming that the transformer is 100% efficient. For a transformer that is 100% efficient, we expect the power on the secondary coil to be equal to the power on the primary coil. So, voltage in the secondary coil multiplied by current in the secondary coil must be equal to voltage in the primary coil multiplied by current in the primary coil. If we make use of that equation, we are going to see that the current in the primary coil will be equal to 90 volts multiplied by 5 amps, all divided by 240 volts to give us a current of 1.875 amps. Then to end question 1, you were supposed to state one advantage of transmitting power at high voltages, of which this helps to prevent heat loss when we transmit power at small or low currents. Moving on to question number 2. With question number 2, you were given a graph which you were supposed to study, a graph of potential difference against current. First and foremost, they said, state the mathematical relation between the current and the potential difference, of which we all know that they are directly proportional. 2a Roman 2. You're supposed to calculate the resistance of the ohmic conductor. As we all know, resistance is given by voltage divided by current. If you take any combination of figures from the given graph and substitute it in the equation R equals to V over I, you will see that the resistance of our ohmic conductor will be equal to 6 ohms. You can make use of any pair of points from the graph given. Moving on to question number 2a, Roman 3. The question says, draw a circuit diagram to show how the results used for plotting the graph were obtained. In your diagram, you expected to include a cell, an ammeter, a voltmeter, a variable resistor, and a conductor. Our expected answer looks like what we have on screen. The main problem I realized is that many struggled to indicate where the voltmeter is supposed to be. When it comes to connection of electrical appliances, you are going to see that our ammeter is supposed to be connected in series, whilst you connect a voltmeter across. Then, the last question. You were given a graph again showing the relationship between potential difference and current for the filament of a light bulb. I would like to believe you all know that the filament of a light bulb is a non-ohmic conductor. That is the reason why you see that the graph curves at higher currencies. Now we were expected to give an explanation to this. The graph curves simply because as current passes through the filament, this causes it to get hot. And at higher currencies, the temperature of the filament is high, and this in turn will also increase its resistance. With this, I have come to the presentation of the solution to our first assignment.